Hello viewers, welcome back to another section of my YouTube channel tutorial. In this video, I'm going to take you through the type 2 of mathematical induction problem, and it focuses on inequality problems. I have a problem here. Prove that 2 to the power n is less than n factorial for n is greater than or equal to 4 using mathematical induction. How do we do this? Mathematical induction follows some algorithm or defined steps to handle the induction process, which we call the principles of mathematical induction. I have done that already in my previous video. Please subscribe to get all those videos and don't forget to like and share. Please watch this video to the end as well. So the first step we are going to use is the base case. I said the base case is the step for proving that this statement we have here is true for the least number of n, or for the least value of n. So see, this is the base case. So my statement p of n should be true for what's the least number of n? Is that n is greater than or equal to 4. So this statement will hold only when n is greater than or equal to 4. So the least number is 4. So n should be true for n equals 4. So what am I going to do? 2 to the power 4 should be less than 4 factorial. And if that's so, 2 to the power 4 is giving me 16 and 4 factorial. What is 4 factorial? 4 factorial is giving me 24. And the sign here is less than. So indeed it's true that 16 is less than 24. Hence, the base case is proved. So once the base case is proved, then you can proceed to the next step because our inequality has satisfied the base case. So let's move to the second step. And the second step is the inductive hypothesis. So for this hypothesis is the assumption that the statement is true. So the assumption that P of n is true for n equals what k. This is an inductive hypothesis which focuses on the assumption that our statement is strictly true for a value n equals k. Hence our statement will change to 2 to the power k less than k factorial for k greater than or equal to 4. Right. So right now our statement is now 2 to the power k less than k factorial for k greater than or equal to 4, and this statement is true. That is the assumption is true. So at the inductive hypothesis stage, you have to make the statement true for a particular constant or a particular value. Here we choose a constant k. Then let's move to the third step, inductive step. In this step, what you're going to do is you have to prove that the statement is true for n equals k plus 1. That is the k plus 1 term, the term that comes afterwards k. So our p of k plus 1 in this stage is going to be 2 to the power k plus 1. That is wherever you see n, you put k plus 1 there. It's less than k plus 1 factorial. So this is what you're going to prove that it's true. If this relationship becomes true, then it means that the statement from the beginning is true for all natural numbers n. In the inductive step, we make good use of the inductive hypothesis. From the hypothesis, we know that 2 to the power k less than k factorial is always true. When you have this expression, it's always true. For that reason, we have to modify this here and see if the relationship here is true. So this is the same as 2 multiplying 2 to the power k less than what? K plus 1 factorial. Since you are dealing with constants, you can't just tell me that 2 multiplying 2 to the power k is always less than this. No, it doesn't make sense. For that reason, we need to use our inductive hypothesis to make this so clear that this part is indeed less than what this part. Now, let's come back to our inductive hypothesis. So here is 2 to the power k is less than k factorial, and you know it's true. So you write it. 2 to the power k is less than k factorial. You know it's true. You will multiply here by 2 to get this. So here by 2, here by what 2. Hence, 2 to the power 2 multiplying 2 to the power k is always less than what? 2 multiplying k factorial. Is that not it? That is another step. So let's go on making this statement true. This is our focus, make this statement true. So now 2 multiplying 2 to the power k is less than this. Now what is this? If you have 2 multiplying k factorial, it is the same as what? 2 open bracket k minus 1 factorial. You get it? Because in factorial, 2 factorial is equal to 2 multiplying 2 minus 1. Do you get it? So you take the factorial term, multiplying by that term minus itself. So 2 multiplying k minus 1 factorial. You can go on k minus 2 factorial. So let's see. From here, I can make 2 multiplying 2 to the power k to be less than what? My 2 k minus 1 factorial. Since our inductive hypothesis was true, always 2 multiplying 2 to the power k is less than this. Now let's come back to our inductive here, this step. 2 to the power 2 multiplying 2 to the power k is less than this. What is this one 2? So if you have k plus 1 factorial, it can be expressed as the k plus 1 itself multiplying this minus 1, that is k, then multiplying this minus 1, k minus 1 factorial, right? If you break this one down, so let's see, we can then convert this side to be what? 2 multiplying 2 to the power k will be less than this, that is k plus 1 k and k minus 1 factorial. Then let's see, from our modification of the inductive step for inductive hypothesis, we realize that 2 multiplying 2 to the power k was always less than 2 multiplying k minus 1 factorial. So if this is less than this, now let's compare this and see. I have k here, I have k here, I have k minus 1 factorial, I have it here. I have another extra term which is k plus 1, and this is 2. It's obviously that k plus 1 will be greater than what? 2. You get it? So depending on the value of k, you add 1, and obviously you get it greater than 2 in most cases. For that reason, this term we have here is bigger than this, and this one here is less than this. Then basically you can use it. You can use this relationship. So 2 to the power 2 to the power k multiplying 2 is less than 2 multiplying k minus 1 factorial. Then this whole thing too is less than this, k plus 1 k multiplying k minus 1 factorial. For that reason, we can clearly see that 2 multiplying 2 to the power k is less than k plus 1 k minus 1 factorial, where everything here is the same as k plus 1 factorial. So see, we can see that this makes our inductive step true, and this is our inductive step, 2 multiplying 2 to the power k. multiplying to the power k is less than k plus 1 factorial. Hence, our statement has been proven to be true. Thank you for joining me in this video. Hope joining me in the subsequent videos. Thank you.